Hello guys, welcome back to the third year guide. This is our fifth video of the Neetcode 150 challenge. Today's question is top k frequent elements. This is a medium problem on Neetcode 150 challenge. So the question states that given an integer array nums and an integer k, return the k most frequent elements within the array. So we have given this nums array 1, 2, 2, 3, 3, 3, k equal to 2. We need to return the most frequent elements within the array. So we will return k most frequent elements. So in this, let's go to drawing board. So we have this question 1, 2, 2, 3, 3, 3. We know that 1 is occurring one time, 2 is occurring two times, and 3 is occurring three times. So we need to return two most frequent. So two most frequent are 2 and 3. So we will return 2, 3. How are we going to solve this problem? So first of all, we need to store the frequency, okay? So we will be having a dictionary, which will store integer, integer, integer. So for every element, we will store its frequency. For example, this is our dictionary. 1 is occurring one time, 2 is occurring two times, 3 is occurring three times. Now we need to somehow only want to get these two values, the one which are having most frequency. So for that, we will need a priority queue of size equal to k, priority queue of k size. Okay. So what is priority queue? Priority queue will always give us sorted data. For example, if we are having 1, 2, 3 in our priority queue, then we will be getting 1 at top. So we can dequeue it and find that this is the value that is the minimum value. Then if we dequeue it, then we will be left with 2 and 3. So if we dequeue it now, then we will get 2, and we after that we dequeue it, now we are left with 3. So that's how we will be solving it. Let me show you how will we do that. For example, this is our dictionary. Okay, this is our dictionary right now. Now we will be using a priority queue. Okay, so first of all, let's say our priority queue is empty. Okay, now we will say add one item, add value 1, and its frequency is 1. So we will be sorting it based on this priority. This is our frequency. It will be our priority. Okay, so it will be on the top. Let's say we will not use it like stack, it as a tree. Let's say this is 1. Okay, and now we will go ahead in the dictionary, and now we are with we will process the 2. Okay, now 2 is having priority 2, so it will be linked with this. Okay, now 2. Now we know that the count of k is 2, the value of k is 2, and this is also having two values inside it, priority queue. Okay, now here comes the twist. When we add 3 to it, okay, we added 3. We know that its priority is 3, its priority is 2, its priority is 1. Okay, now we know that we have exceeded the k limit. Now our size is greater than k. Okay, now what we will do is we will dequeue it. Now when we dequeue it, we will remove this element from it. So at the end, we will be left with two elements, which will be k elements, and we will return these values. So as we are having these values, we will just uh, traverse it and add it to our answer array and return. Let's quickly check how will we write the code of this. So first of all, we need to store the frequency. So we will use a dictionary. where frequency is equal to new dictionary and command for each element we will announce if frequency that is key none, if it does not contain, then we will initialize it. We will say frequency of dot add none comma 0, and after that we will just increment it frequency of none plus plus. Now we are having the frequency array, frequency dictionary. Now we need to declare priority queue. We call it map. It's not a map, just call it priority queue. PQ is equal to new queue. It will be int, and we will just declare it as it is, as it will be a minimum heap, as it will give minimum value on top. We can also do it backwards, but we don't need that, so we are doing it like this. Now, for each where item in, now we will traverse this frequency here. I love frequency, where each item frequency here means that just add it to our priority queue. So pq dot nq item dot key comma item dot value. Now, if this is the important part, if pq dot count at any time is greater than k, now we need to dequeue. Okay, pq dot dequeue. As I told you, like this, if we have 1, 2, 3, we only need, if the case 2, then we only need 2 values inside our priority queue. But now the values of size of priority queue is greater than k, which is 2, so we will dequeue it. So we don't need this value, as this is redundant and we don't need it. This is minimum value, the most minimum value. Then let's store in it our answer array, and answer is equal to answer array is equal to new int. It will also be of size k, because we know that if k is 2, then we are returning 2 values. If k is 1, then we are returning 1 value. Then we'll write another for each, and not for each, but it is time for loop, int I is equal to 0, I is less than k, I plus plus. This can be in any order, so we don't. We can also like start it from reverse, like I is equal to k minus 1, and it will go till 0. So we'll say answer of I is equal to pq dot dq. And at the end we will return answer. Answer is correct. And okay. Let's try to run it. We're getting an error. The dictionary entry does not contain a definition if it contains. Okay. So I forgot to use capital camel case letters. Yeah, it's working. Let's try to submit it. Yeah, it's also working. Currently, it is taking n time here, time complexity n here. Then it's using n into while entering it uses log n. So n log n here, and so the total time complexity is n log n, and space complexity is we are using two dictionaries, like two sets of n variables. So space complexity is n. Can we reduce it? Can we reduce the time of complexity to n? Yes, we can. So we can use counting sort. The main reason of this problem was that to teach you how counting sort works. So it will be similar to frequency. This frequency array will remain same. The dictionary that we use will remain same. We just need to change this priority queue. We don't need a priority queue here. For example, let me tell you how we will do this. Let's say how it works. Let's say we have this dictionary. Okay, one is occurring one times, two is two times, three is three times. Now we will create. Let's say we have this 6 elements, right? In here we have these 6 elements. 1, 2, 2, 3, 3, 3. Now each elements, what is the maximum frequency can it have? Like one, let's say for one, the maximum frequency it can have is 1 if all the elements in the array is 1. Okay, so 1, 2, 3, 4, 5, 6. So the 1 can have maximum frequency of 6. Similarly, every element can have a maximum frequency of the total number of elements it has. Like if it has 7 elements, then the maximum frequency an element can have is 7. So we will create an array of that much length. Like for example, currently this is having 6, so I have created the array of size 7. So basically it will go from 0, 1, 2, 3, 4, 5, 6. So currently it is having 7 boxes, which is 6 plus 1. Okay, so now for each index it will work as a key. Currently this is working as a key. So currently now how much 1 is occurring one time, right? So we will write here 1 is occurring one time. So this is the frequency. This is working as frequency, although it's an index, but we use it like frequency. So 1 is occurring one time. Okay, now 2 is occurring 2 times, 3 is occurring 3 times. Now let's say we had some another element, like here we have some 4 value which was also occurring 2 times. Let's say they have here 1, 2, 2, 3, 3, 3, and 4, 4. So the total elements are now 6 plus 2, 8. So we will just increase the size of the array, 7, 8. Now 4 is also having 2 frequency. So we will add it here. So every index has its own list of items. So we need to create an array of list. Let's say list of integers. So we will create an array of size. How much? Size will be equal to n plus 1. So how will it help to solve this problem? So we know that if this is the frequency, so the maximum frequency is 8. So we will start looping from here and we'll go backwards. Now we will keep an answer array of size k. We know that we need to return k elements, right? Now if we go here, if the list is null, then we go here. List is null, go here, go here, go here. Now list is not null, so maximum frequency we are having is 3. So at the end of the answer, let's say if we are returning 2 elements, then we are having 0 and 1 index. Now at first index I will add this 3. Okay, now I will go back. Now here comes the twist. Now we are having 2 elements. Now we can use any of this element, like 4 or 2. Let's say we write here 4. So this is also valid, and 2 comma 3, this is also valid. But the answer is stating that you can assume that the answer is unique. So they will not give us anything like this array, but some other, so that the answer is unique. So that's how we'll solve this problem. Let's also quickly check how will we write the code. We just need to tweak some code here. Frequency will remain same. Frequency will remain same. Now we just need to create a list of uh, list int. Let's also call it list of array, list array, list of int. It will be of size n plus 1. What is the int? Int n equal to num dot length. Now for every index we will for each item in frequency. So if list array of I of item dot value, we know that item dot value is the frequency, so it will become our index. You know that this is our frequency, right? So 1 is key, which is the element. 1 is occurring one time, it means this is frequency. So it will be it will work as our index value. If this is equal to null, then we need to initialize this list array of item dot value is equal to new list int. Okay. Else this is if this is not if this is not null, then we will do list array of item dot value is dot add. Dot add means we need to add it to our array. Add item dot key. Okay, I hope it will work. So now, we are having with this list array. Now we need to now we need to traverse it. So we will go from n to greater than equal to 0. We will this, as we know, we will go backwards. So if at 8 position this is null, then we'll do nothing. 7 will do nothing. 6 will do nothing. Nothing. But if we don't have this null position, then we need to somehow enter it to our answer array. Okay, that's how we are trying to do it. So if list of array of current element, it is I, list array of I is equal to null. So let's say if it is not equal to null, because if it is equal to null, then we don't have to do anything. If it is not equal to null, then we will check for int I is equal, for int j is equal to 0. J is less than list array dot count j plus plus. Okay. Now we will add it to our answer array. Let's say we have this k. We know that our answer array will also be of k size, so we can use this k. Okay, so k, if the k is 2, then we can just do one subtraction to it, so the k will become 1. Now we can add this to our answer array. So list array of I of j, so we will add it to our answer array. Now if k is equal to 0, then we will do nothing but return an array, return our answer. Otherwise we will do k minus minus. So I think it should work now. Let's try to run it. Okay, so we are having greater less than cannot be applied to operand of type int and method. We are using less than here. And for int j is equal to 0, j is less than list array of I, sorry, list array of I dot count. It is running fine now. Let's try to submit it. So this specific uh, now our method is using big of n time complexity. So because for we are using n time complexity, n time complexity again, and k time complexity. So our answer will be in big of n time complexity and also big of k, big of n space complexity. I hope you understand how can we solve this problem. I will see you in next one.